Solution for the mock exam for trig functions, equation identities. Number 1, let f of t equals a cosine b of t minus c plus d, where t is greater than or equal to 0. Part of the graph of y equals f of t is shown below. Take a look at this graph here. We can see that there is almost one cycle of a trig function that could be expressed as sine or cosine. In this particular case, they're asking us to express it as cosine. Let's see. There are two critical points that we should look at. One is t equals 3, y equals 29, which would be this point here. And then another point at t equals 9, y equals 15, which would be this point here. Okay, and those are maximum minimum values, which are critical for finding out the parameters of the f of t function a, b, c, and d. So the first thing that the problem asks us to do is to find the value of a, which is the amplitude. Remember, the amplitude is basically the vertical distance from the mean line to the maximum or the mean line to the minimum. That's the way I prefer to think about it. If you think about it that way, then you could say, oh, the mean line looks like it would be halfway between 29 and 15 height. That would be, there's 14 units between 29 and 15. That means that this would be 7 and this would be 7, meaning a would be equal to 7. The other way you could do it is you could memorize the formula being a is equal to max minus min y values divided by 2. So you have 29 minus 15 divided by 2, which is equal to 14 divided by 2, which is equal to 7. Okay, let's move on to the next one. So part B. Part B asks us to show that b is equal to pi over 6. Remember, b, there's a formula that we should memorize for b, and you could memorize it in one of three ways. One is that bx equals 2 pi. The advantage of memorizing this way is there's only one formula to memorize, where x is the period. Another way of memorizing it is b equals 2 pi over period, or period equals 2 pi over b. This is also pretty easy to memorize because of the symmetry between this one and this one. So in this particular case, let's say, okay, we want to find out what b is equal to from looking at this, the information that we have. Remember that it's pretty hard to see what b is equal to just from looking at the trig function. It's a lot easier to see what the period is equal to. So let's do that first. Let's figure out what the period is from looking at the information here. So, for example, we have here that the horizontal coordinate of the maximum is 3 and the horizontal coordinate of the minimum is 9. Which means that the distance between, the horizontal distance between the minimum and the maximum is going to be 9 minus 3, or 6, right? And remember that the distance between the maximum and the minimum is half a cycle. If you have the distance between a maximum and a maximum horizontally, that would be a full cycle. If you have the distance between a minimum and a minimum horizontally, that would also be a full cycle. But if you have a distance between a maximum and a minimum, that's only half a cycle. So our half cycle is 6 long, so our full cycle will be 12 long. So that basically means that our period is 12. So we could figure out what b is by using the formula b equals 2 pi over period, which would be b equals 2 pi over 12, which would be equal to pi over 6. So we demonstrate that b is pi over 6 by first finding that the period is equal to 12. Okay, so let's go down and look at, I said that was B, but actually it's A2. Let's look at A3. Find the value of D. Now remember, to find the value of D, what we're looking for is the mean line height. And there's a couple ways to do it. The first way is to do exactly what I did at the very beginning. I said, hey, the maximum height is 29, the minimum height is 15, halfway between those two, you take the difference of the two, you get 14, you divide 14 by 2, you get 7. Half the distance between the two, or half the height between the two would be at 15 plus 7, which would be 22, or it would be 29 minus 7, which would also be 22. So the height of the mean line is 22, and that is also equal to D. The other way to do it is there's a formula for D. You memorize that, and that would be that the minimum y value plus the maximum y value divided by 2 is equal to the D value. And so if you did that, you'd get 29 plus 15 divided by 2, which is equal to 44 divided by 2. 44? No, 34? 29 plus 15, 44 divided by 2 is equal to 22. So either way you get 22, right? So the D value is equal to 22. And part 4, write down a value for C. So C is always at the end. And basically what C is the horizontal translation of the parent function to the current function. And the parent function in this case would be cosine, because they want us to do it in terms of cosine. So what does that look like? Cosine, remember, always starts at its maximum value, goes down, and goes up again. Okay, so here they have conveniently marked for us the maximum value of the transformed function. So we can already see that this point M has been horizontally translated to the right by 3 units, right? So that means C equals 3, because C is equal to the horizontal translation of the function. We know that the parent function starts at the maximum value because the parent function is cosine, and the maximum value has been obviously shifted 3 units to the right because the coordinates of the maximum point were given to us as 3, 29. So C is equal to 3. Okay, and the next part says the transformation P is given by a horizontal stretch of a scale factor of 1/2, followed by a translation of vector 3, -10. Now remember, this is used very sparsely in the course, but it is part of the syllabus. We've used it in the quadratics unit, we've used it a little bit in the transformations unit. Basically what this notation says is that 3 is a horizontal translation, and then -10 is a vertical translation. And of course, positive means right or up. Okay, so in this case, they want us to do 2 transformations. The first transformation is a horizontal stretch of a scale factor of 1/2. That's a little bit tricky because a horizontal stretch by 1/2 is actually a compression, right? It's going to be half the size that it was before. So what we're going to do is we're going to take the entire function we have here at the top, and we're going to horizontally shrink it, and then we're going to translate it by 3, -10. Make sure you do it in that order. Now it's obviously pretty complex to do that with the entire function, so what they want us to do is to do it with a single point to show us we can do it with a single point. Let me just erase some of this. Okay. So we start with the point M, which is at 3, 29. What they want us to do is they want us to horizontally stretch this point by 1/2, which means that its horizontal coordinate 3 is going to be 1/2 of what it was before. Basically, that means that the point M is going to move to this point here, which would be 1.5, 29, right? Because instead of being at 3, it's going to be at 1.5 because 1.5 is 50% of 3, or 1/2 of 3. The next step is to do the translation 3, -10. So we would move it 3 to the right, and then -10 would be 10 down. So 3 to the right, starting at 1.5, 29, the next point would be around here, and it would be 1.5 plus 3, or 4.5, 29. And then finally we want to move it down 10. And so that would mean that it would be around here, right? And that point would be 4.5 because the x-coordinate didn't change, and then 29 minus 10, which would be 19 after the translation down. Okay, and you need to make sure you do it in the right order. Make sure you do the horizontal shrink first, then you go to this point here. And then as for doing the vertical and horizontal translations, it doesn't really matter which order you do it in because one affects only the x-coordinate, the other affects only the y-coordinate, so it doesn't make any difference which order you do it. You're going to get 4.5, 19 anyway. So let's write that one down. Okay. And next page, we're going to continue with this problem. It says the graph of G is the image of the graph of F under P. So basically what they want us to do here is they want us to actually find the transformed version of the function. And that might seem like a big challenge, but actually they already gave us the A value to start us off, right? We already know that. And I'm just going to write down the original function that we came up with, which was that A equals 7, that B equals pi over 6, that C is equal to 3, and D is equal to 22. I'm going to write that out first, okay? So it would be 7 cosine pi over 6 x, or not x, it would be t, right? T minus 3 plus 22. That was our original model. And now what we're going to do is we're going to change this model based on the transformation P. If you remember, we're going to do a horizontal stretch by a factor of 1/2, and then we're going to do a translation by the vector 3, -10. So let's see what's going to be affected here. They basically said that 7 is the same as before. If we do a horizontal stretch and a horizontal translation and a vertical translation, does that affect your B value? Yeah, the B value basically says how wide the function is. So this is going to be affected by the horizontal stretch in particular. Is the horizontal translation going to be affected? Yes, because we are going to be translating it 3 to the right, right? And finally, is the D value going to be affected? Yes, it will, because we're going to be translating it 10 units down. Okay, and we do know that the new M dash transformed location of the maximum is now 4.5, 19. That really helps us because the C value is one of the trickiest things to find, and the C value is given by the 4.5 here. Okay, it used to be 3. Now that we did the transformation P, we already found that the maximum point is now at 4.5, 19. We know that the new C value is going to be 4.5. So we already know that this is going to be 4.5. Now we also we have horizontally stretched it by a factor of 1/2, which means that instead the period before, remember, was I can't remember what it was. The period before was 12. So the period before was 12. And now that we did a horizontal stretch by a factor of 1/2, the new period is going to be 6, right? So before the B value was pi over 6, with a new period of 6, the value of the B was going to be 2 pi divided by 6, which is pi over 3. So our new B value is going to be pi over 3. So this, instead of pi over 6, it's going to be pi over 3. And then finally, our D value. Our D value before was 22. But now that we are going to move it 10 units down, then it should be 22 minus 10, which would be 12. Now, did the horizontal compression affect the D value? No. Did the horizontal translation affect the D value? No. So the only thing that affects the D value is the vertical translation of down 10. So I put that there. So there's all of our changes. So I'm going to write it down here. So g of t is equal to 7 cosine pi over 3 t minus 4.5 plus 12. Okay. Second problem. The straight line with equation y equals 3/4 x makes an acute angle theta with the x-axis. So, basically, this is an equation of a line with no y-intercept. So we could just kind of make it like that, okay? And it says it makes an acute angle theta with the x-axis. That would be this angle here. And rise over run tells us that the rise is 3 and the run is 4. So that means that the rise is 3 and the run is 4. I kind of drew this triangle a little bit tall, although it should be wider than it is tall, right? Let me fix that. Okay. And then it says to write down the value of tangent theta. Okay, this is a non-calculator problem. The reason why we know that what the tangent value is because we can look at the drawing and we can see that the opposite over the adjacent in this case is 3/4. So the value of tangent theta is 3/4, which is 3/4, which is the same as the slope actually. Then it says to find the value of sine 2 theta. Okay, now this is also non-calculator, so how are we supposed to even find the value of sine 2 theta if we don't even know what theta is? Well, remember, this is the Trig Identities unit. There's a formula for sine 2 theta, which if we look at the formula sheet is 2 sine theta cosine theta. So if we know the value of sine theta or cosine theta, then we can figure out what sine 2 theta would be. Now, we know the value of tangent theta. Do we know the value of sine theta cosine theta? Well, actually, if we look at the drawing we just made, we could use Pythagorean's theorem to find the unknown length of the hypotenuse, and then we could figure out sine theta and cosine theta from looking at the drawing. So using Pythagorean's theorem, we know that this hypotenuse is equal to 3 squared plus 4 squared, which is equal to 9 plus 16, which is equal to 25. So the hypotenuse is equal to 5 because it's the square root of 25. So we know that this unknown side is 5. And so that means we can figure out that the sine is equal to 3/5. And we know that the cosine is equal to 4/5 because we just used the drawing and opposite over hypotenuse and adjacent over hypotenuse and multiply that times 2. And that is going to equal to the sine of 2 theta. By the way, this triangle here is the famous 3-4-5 triangle, which is often found in SAT problems and vestibular, and that's something that is pretty easy to memorize, and you should memorize it. So let's multiply 2 times 3 times 4. That'll give us 24 for the numerator, and the denominator would be 5 times 5, which would be 25. So sine of 2 theta is equal to 24 divided by 25. What about the next one, which asks us for the cosine of 2 theta? So the cosine of 2 theta you could find by a couple different ways. One of the ways is using the Pythagorean identity, which is that sine squared plus cosine squared of a given angle is equal to 1. So we know that the cosine of 2 theta, or the sine of 2 theta, is 24/25. So the sine squared would be 24/25 squared, and then cosine squared is unknown, and that's equal to 1. And we could use algebra to solve for cosine squared, and then we could take the square root and find the cosine. Okay, so that's one way, is to use the Pythagorean identity. The other way is to use the other trig identities that are in a formula booklet for cosine of 2 theta. Remember, cosine of 2 theta has 2 trig identities. One of them is based on sine theta, and the other one is based on cosine theta. So we'll write both of them out to see which one is useful for this particular case. So cosine 2 theta could equal 2 cosine squared theta minus 1, or it could equal 1 minus 2 sine squared theta. Either one of these can be used to find cosine 2 theta. Which one is convenient in this? Oh, by the way, there's a third one, which is usually never the best option, which is cosine squared theta minus sine squared theta. The reason why this is not very useful is because it requires you to know both sine and cosine, whereas this only requires that you know sine, and this only requires that you know cosine. So in most cases, you're going to know cosine or sine, but you're not going to know both. So that's why we kind of avoid the third one. But in this particular case, we actually do know both, right? Because we just found both of them for sine 2 theta up here. Right? So let's try it with a couple of these options just to see which one is the best. Let's see. So, for example, 2 cosine squared minus 1, we know that the cosine is equal to 4 over 5, right? So it would be 2 times 4 over 5 squared minus 1. So that would be 2 times 16 over 25 minus 1, which is equal to 32 over 25 minus 1, which is equal to 32 over 25 minus 25 over 25, which is equal to 7 over 25. Okay, so cosine 2 theta is equal to 7 over 25. We could also do it with this option here, which I said is the one to avoid. So cosine squared theta would be, like I said, 4 over 5 squared, and then sine squared theta would be 3 over 5 squared, and so that would be equal to 16 over 25 minus 9 over 25, which is also equal to 7 over 25. So you can see that using any of these three formulas, you're going to get 7 over 25 for the cosine of 2 theta. That's it.